anything in Big Alls area. Or something, who knows? Ugh.
Almost the moment. Very far situation. So I asked for the prayer that you cast me over it. I pray
Hello, people.
that you bring
Morning.
Good morning.
I don't know if it's good, but it's definitely morning. For some reason, I've been having troubles getting up in the mornings these days. And I think it has to do with me not managing my,
the situation that she
okay, somebody's unmuted and I'm hearing a bit of their conversation. So you might want to unmute you might want to mute yourself.
And then you clear her mind, Father God, of all anxiety, of all loneliness, Father God, of any negative thoughts, Father God. I ask that you clear her mind, Father God. And
Oh, come on, stupid machine.
I ask that you lead her. I ask that you guide her, Father God, in her decision making, Father God. Lord, may she know that she's not alone, Father God. May she know that when she's feeling lonely, Lord, to turn to you. Turn to you, Lord God. She prays and she worships.
Sorry, I'm a bit late this morning. Almost got away on time. Not like yesterday. I mean, what are you doing? And the computer is running real slow. It's running behind me as far as it'll catch up. Maximize that. Not doing. That's really wrong way. Yeah. I love playing with technology, but not when I'm trying to get things going. Okay. So the next thing is to pull up the PowerPoint. Back to there, law of signs. We already started law of signs, right?
We already did law of signs. We're in law of cosine.
We just got to the slide, right?
Yes.
It was supposed to do that. I don't know why it didn't do that. Okay. There's sometimes where we can't use the law of sines, but sometimes the law of cosines might be a quicker and easier way to find certain numbers. With the law of sines, there's three equations. There's three equations that we need to be concerned with. Oops, it had it on. Pull the zoom up and hit that, and here we go. So solving side angle side triangles and solving side triangles, right? If you have all three sides, but you don't know any of the angles, we can't use the law of sines because we don't have any angles to take the sine of. And then applied problems. In my day, they were called word problems. Okay. Now, the law of sines used to solve case 1 and 2 of an oblique triangle. The law of cosines is used to solve cases 3 and 4. Okay, where two sides and you have the included angle. To do law of sines, you need a side and the angle opposite it. This and this angle is in between the two known sides. So there's no way to find out using law of sines. There's no way to do it. And with the three sides that are known, we already discussed that. So here are the three formulas to find A, B, and C. The two sides you know, and the angle in between them. Oh, by the way, what's the cosine of 90 degrees? Cosine of 90, think of the unit circle.
0.
0. So if I knew the two lengths of the sides of the triangle and cosine of 90 was 0, then these three drop out and all you're left with is the Pythagorean theorem. Ta-da! So it works in all cases. And then you could use the law of sines to find the missing angles. But the C value, I mean, the A, B, and C value are the sides opposite the included angle for side angle side. And if you don't know the angle, but you know all three sides, this still works, because then all you're going to end up using is cosine inverse, the inverse of cosine, otherwise known as arc sine, or arc cosine. So these formulas will still be able to be used. So the square of one side of a triangle equals the sum of the squares of the other two sides minus twice their product times the cosine of their included angle. And this is the verbal description of what's happening with these three formulas. So the non-included side, the square of the non-included side equals the square, the the unknown side equals the sum of the square of the two known sides minus twice their product times the cosine of the included angle. Of the angle created by those two sides. For me, the trick here to remember is just remembering one of the formulas and just realizing that this is a side I don't know. These are the sides I do know. And this is the angle between those two sides. So everything here is a side angle side. Now, if you know all three sides and you're trying to find the angles, then all you really need to do is find one of the angles this way, and then you can use the law of sines to find another angle, and then use the sum of the angles is the sum of the angle measures is 180 to find the third one. The square of the side we do not know equals the sum of the squares of the sides we do know minus twice their product times the cosine of the included angle. And then you just take the square root of the mess and you're done. So we have 16 plus 25 minus, what is that, 80 times the cosine of 50 degrees. So we have, what is this? 30.
40.
What?
4 times 5, 20, 20 times 2, 40.
40. Thank you. I had 40 in my head, so that's why I doubled that. Thank you. 41, right? 41 minus 40 cosine 50 degrees, and that's what c squared is. So this is a calculator problem. Yeah, keep your calculators handy. Just remember.
Is it going to be decimal?
The whole thing? No.
I got
Yeah.
15.
Excuse me?
I got 15.
Okay, so c squared equals 15 point what?
2885.
2885. Yeah, always go to 4 decimal places until you're done. And then round. So now that's what C, did anybody get anything different? In other words, can people verify that he was
it's
correct?
13.2. That's right.
Okay, cool. Okay, so now we take the square root of both sides, and we're not concerned about the sign because we know the sign has to be positive because it's the length of a side, and with distance, we had a lot of apps open. Okay. And what's the square root of 15.2887885? Excuse me.
3.91. How many decimals?
3.9. Oh, give me 4.
101.
10 round, and this would round to 3.9. 3.91. And it all depends upon how many decimal places they ask for. and they will ask for a number of decimal places, and you just need to decide which one you're gonna use. Okay. So let's see, they're gonna do it the same way I did. Yeah, they went to 2 decimal places. Which is what I would do on a test. I would want 2 decimal places. But use more decimal places than your final answer needs to be in. Because it's more accurate that way. Okay. So side C is approximately the length of 3.91 units. Need to add the units. Because we're talking about a length, we're not just talking about abstract numbers, we're talking about a length. And since we weren't said how long, what the unit is, we use the word units. So if we went to find the area here, it'd be square units, using the word units because we didn't specify the measuring system. You will find I disagree with a lot of authors on how they conduct their business. You know, they're the ones with the PhDs. And all I have is a master's. And a lot of people in mathematics, especially the PhD holders, kind of scoff at my master's. Because it's a master's of arts, not a master of science. And it's a master of arts in mathematics with a concentration on teaching mathematics. So, anyway. So to find angles A and B, we either use the law of cosines or the law of sines or the law of cosines. So we could use either one to go that route. It is preferable to use the law of cosines because it will lead to an equation with one solution, whether solving for A or B. The law of sines could lead to an equation with 2 solutions. So using, and that would need to be checked to determine which solution fits the given data. Okay. Law of sines can be used when seeking angle opposite the smaller side, since it is acute. But they're going to use law of cosines to find the other 2 sides. I mean, the other 2 angles. So, all right, so they go through and they do the algebra to isolate the angle A. And so they subtracted A from both sides and added 2 BC cosine A to both sides. So that's how they got this expression. And then they're going to divide by 2 BC. And then they're going to take they put numbers in there. Yeah, go ahead. I used the rounded here, but maybe not. And then take the inverse cosine of whatever you get in here. And we get 56.6. I mean 51.6. So you have 50 degrees. Now you have 51.6 degrees. So that's 101.6 degrees, which means the other angle is going to be 79.4 degrees. Because then they'll add up to 180. So this was angle A. and this would be angle B. Now I'm curious to see if they go ahead and use the law of cosines to find angle B. And we'll move on to the next slide, unless somebody still needs to see it. Oops. That was not what I wanted.
Excuse me.
Yes.
I'm looking like at the very end where they move cosine to yeah. How do you why is it like an inverse?
Well,
That's how
because
you get rid of it?
the cosine of A equals this in here. Right? The cosine of A equals this, so I need to take the cosine inverse to find out what A is.
Oh, okay. All right.
All right, that makes
All right,
sense?
thank you. Yeah, it makes sense. Thank you.
Okay. For B, yeah, they went ahead and used the law of cosines again. And so they end up doing the same thing, but they're gonna use A and C in here and B over here because we're trying to find angle B. And so they're gonna solve it the same way by taking the inverse cosine of both sides here. And whatever, and I would calculate this number first and then take its inverse cosine, making sure you go down to 4 or more decimal places for the number you're putting into cosine inverse. And I got 78.4. Oh, wow. Yeah. I subtracted wrong. Did anybody catch that? Yeah. So either you can either find that third angle by doing the law of cosines, or you could do it just using the fact that they add up to 180, provided you do your subtraction correctly. And I'll get in a hurry to do that. So now we know all three sides. So you pick an angle to find. So doing this is like doing this when we found an angle. So we're just going to do this 3 times, or do it twice and then find, or do it once and then use law of sine. Either way. So I'm wondering which one they're going to use. Okay, that's interesting. They're going to use the law of cosines to find angle A. I think this is now, can't I? Right. And previously, they already solved for the cosine of A. They're using A squared equals B squared plus C squared minus 2 BC cosine A and then solve for cosine A. And then now we know all these numbers, we know A is 5, and B is 4, and C is 7. So this is 16 plus 49 minus 25 divided by 2 times 4 times 7. So this is 56 down here. Okay, and it reduces to the fraction 5/7. Yeah, it's a good idea to calculate this all down, because this should be a number less than 1. Between 0 and 1. Because it has to be positive. And you do cosine inverse on 5/7, which gives us 44.4 degrees. Put this note here, solve for cosine A. And then once you get cosine A and you get a number on this other side, then you take the inverse cosine. See, this is how I would solve those others. I first find out what goes inside, and then I take the inverse cosine of that number. All right, so you always want to make sure that this number, that the cosine you get, is going to be a fraction that's less than 1. Otherwise, it doesn't work. Because cosine gives you numbers between -1 and 1. That's the range of cosine and sine. Okay. And then for B, cosine B, they're using B squared equals A squared plus C squared minus 2AC cosine B. And then they solve for cosine B. Which is what they have done here. And then they just put the numbers in appropriately. You got 29/35. 29/35 is a proper fraction. So they did the math correctly. Okay, and then you just do inverse cosine of that and get 34.4. I mean 34.2. 34.0 degrees. And what was the other one? I forgot.
44.4.
44.4?
Yes.
Oh, that's nice. And so that gives us what, 78.4 degrees? And so the other angle is going to be 101.6 degrees. So this is angle C. This was angle A. This was angle B. And then the last, okay, so now I use A and B to find C. They didn't go through the trouble of using the law of cosines to find angle C, which I think is a good idea. When you have a more complicated formula, this is a more complicated formula than this is. When you have a more complicated formula, there's more room for error. You write down the wrong number. You have Mr. Reed's problem, and you type it into the calculator incorrectly. I could have sworn I hit a 2 and you hit a 3, or you hit the 2 and the 3, so you enter 23 instead of just 2. So those kinds of errors happen. That's why when you use the calculator, you do it more than once. to check your work, to make sure something they get punched incorrectly. Or the calculator's down, the batteries are dying in the calculator and it just freaks out and just gives you random number entries. I've had that happen. Oh, weird. And so, yeah. 101.6. Wait, isn't there a radio station in San Antonio that has those numbers? 101.6? Is it 101.6? Anyway. It plays a lot of the music on Wi-Fi. I like it too, but I tend towards hard rock and roll, but that's my liking. Also like country, and I love the blues. And when I taught down at Pearsall, I discovered that I like Tejano music. The only kind of music I really don't care for is hip hop or rap. I guess that shows my age. Okay. Motorized boat leaves Naval, Florida, bound for Key West, 150 miles away, maintaining constant speed of 15 miles per hour, but encountering heavy crosswinds and strong currents. The crew finds after 4 hours they're off by 20 degrees. How far is a sailboat from Key West at this time? Through what angle should the sailboat turn to correct its course? Pictures never prove, but they help. Okay, this is where I'm starting from. This is where they're going. They're going this distance here, which is 150 miles. They went at a constant speed of 15 miles per hour, and they did it for 4 hours. How long had they been sailing? I mean, how far had they sailed? Huh?
Wouldn't it be 15 times 4?
Exactly. So it blew them off 20 degrees off of their direction that they were going. But this, and so 15, driving 15 miles per hour, and after 4 hours, that's 4 times 15. So they've gone 60 miles. They want to know how far from Key West they are and what angle they need to turn. Just arbitrarily, I'm going to say this is A and this is angle B. So this is C and this is B. Is that? Oh, you know what? It's not on the screen. I apologize. Wrong way. Okay. So the picture helps because I can see what's going on. I need the picture. I just can't get it from the words myself. I need the picture.
Why was 60 BB and not C? Why was 60 BB and not C on the picture? Why would it be B and not C? 60 miles. Because isn't it on the other side of C?
Oh, yeah. It's opposite B, so it's B and this is C. Sorry, my apologies. And so we want to find this length A up here. So we have A squared is going to equal B squared plus C squared minus 2BC times the cosine of A. I know B is 150, so 150 squared. I know C is 60, so that's 60 squared. And so this is going to be 2 times 150 times 60 times the cosine of 20. Whoops. See, 15 squared is 225, so that's going to be 2,250. Plus 60 squared is 3,600. And then this is 300 times, so that's going to be 800 times the cosine of 20. Please verify that my numbers are correct. Because doing it in my head and doing it quickly.
I thought it was 22,500
2 zeros, yes.
and 3,600.
3,600,
And then
Yeah, I see.
minus 18,000.
18,000?
Yes.
Oh, yeah, I lost a zero. And 20 is going to be, cosine of 20 is going to be a number close to 1. Whoa. Well, when I add these two together, that gives me what? 26100, 26,100
Yes.
minus, and so this is going to be less than 1,800. I mean 18,000. So what's the cosine of 20 to 4 decimal places?
The cosine is 0.939.
939.
Seven.
So. And so when you multiply those two together, what do you get?
9,185.5328. Not, I'm getting the wrong.
Yeah, 1,800 times. Yeah, that's your final answer, right?
Yeah.
Okay. No, I want 18,000 times the cosine of 20.
16,914.4672.
And then when subtracting, yeah, that's going to be 9,000 what?
185.5328.
And that's A squared, so what is A? Taking the square root of both numbers. Yeah, I know I'm writing kind of small here, so you may not be able to read it. 1895.53, and we're just gonna end up dropping we're gonna round this to the nearest mile.
95.84.
95.84.
You want all of that?
What?
Do you want more decimals?
No, just 2 decimals. So that's how many miles they're away. And what's that angle supposed to be? And how much time has been added to the trip? So if they're gonna, so we got this number, since we got this number, all we need to do is divide this by the miles per hour, and that gives us how many hours it'll take. But, so, okay. Yeah, they got the same triangle, only theirs is more accurate than mine is, because Key West is almost due south of Naples, so. My grandmother used to winter in Naples. They lived in Michigan. So she and her husband would load up the motorhome and drive down to Naples with the rest of us winter Floridians. Okay. So using to find this length over here using the law of cosine. Oh, they're assigning this angle A. Okay. So what I'm labeling angle A is the 20-degree angle, but they're gonna label the angle they need to find as that one. So they found it the same way we did. Yeah, and they rounded to just the 2 decimals and then took the square root and rounded to 1 decimal. So this is 95.8 miles, almost 96 miles. And so the sailboat is about 96 miles from Key West. Okay. And then to find that angle that is missing, we can use the law of cosines again, because we know these two sides, we know all 3 sides, and so we just need to find this angle. Okay. So the 150 miles is opposite the angle we're trying to find. And we found this length over here. So we had the 96 plus the 96 squared, and so then we just solve for the cosine A. And cosine A happens to be a negative cosine. Well, that means it's going to be more than 90 degrees. Right? Cosine is negative in the second and third quadrants. See, I keep referring back to the unit circle. So that means that angle is an obtuse angle. But which angle is it? So we do the inverse cosine and get 147 degrees. So it's slightly more than that. So 147 degrees. So that's how many degrees I need to change their variant. There's 180. Okay. Minus that. 32. What? Turn through an angle of about 32 degrees. I don't see that. Oh, they're trying to find this angle to change, to correct their change so they can go this way. Because they're going this way and they want to pivot. So now they're pointed down this way. So it's a supplementary angle to this angle.
So 80 minus.
So that's why they did the 180 there. And yeah, okay. So this is our angle theta here, which is what they were trying to I think so, yeah, in my picture here. They want to change their path, which is going that way, to this path. And so if this is 147 point whatever 0.2, then this angle will be the what did they say, 32.8. So they're changing their they're changing their course, so they'll go the correct direction. Okay. Okay, so they were asking how many miles, how much more time is added? That was the question? Because they don't always restate the question. I misread the question. Which is not one of the ways of how to solve a problem. You read everything, you read it more than once, you read it more than twice, you read it more than 3 times. So you totally understand what it's saying. How much time has been added to the trip? Well, the trip of 150 miles being traveled at 15 miles per hour is 10 hours. But now we have 60 miles plus the 96 miles being divided by the 15 miles per hour. And so they had 156 divided by 15,
10.4.
which is 10.4. So they're only adding 0.4 hours to the trip. How much time is 0.4 hours?
15 minutes.
20 minutes?
15.
15. No. 15 minutes would be a quarter of an hour. That'd be 0.25. 0.4 times 60. That's 24 minutes.
Oh, yeah. So,
Am I going the wrong way? No. Oh, I backed up, that's why. All the way to the beginning. Okay. So it's only 6 miles longer. So you divide the 6 by the 15, which gives us the 0.4, which is 24 minutes. Okay. Area of a triangle. There's more than one way to find the area of a triangle. Most of the ways you've learned how to find the area of a triangle is 1/2 length times 1/2 times base times height. Okay, you were given those nice little formula charts to take the state test. But the area of a triangle is 1/2 base times height, or the base times the height divided by 2. Either way works. If one of these numbers is even, you take half of it and then you just multiply. Okay. But there's other formulas, okay? So with triangles, this would be the base, and this is its perpendicular height. So whatever the triangle is, and whatever you choose the base to be, then the height is derived from that base. So we have several different ways of looking at this. And so the height does not necessarily need to be inside the triangle. So that's something to be made aware of. Yeah, I know in those state tests, they love to put these types of triangles. So. Find the area of a side angle side triangles. And find the area of side triangles. There's also something called Herod's rule, which where you find the semi-perimeter. And then I can't fully remember that formula right now. Okay, so and technically drawn to a line that contains the base. So H is the altitude, meaning how tall is it? Its height, drawn to that base. And technically, this is incorrect. It should say drawn to the line containing the base. So that's why we have this situation. The line containing the base, well, it actually hits the base in these two instances. And with a right triangle, one of the sides is one of the legs of the right triangle is the base, and the other leg is the height, or vice versa. So, still holds. Side angle side. So if you don't know the height, but you know two of the sides and the included angle. So here they're giving us three formulas, but it's basically just one formula. These two sides form this angle. These two sides form this angle. These two sides form this angle. So they're all the same formula, they're just taking it, looking at the same triangle and how that formula looks for those three different angles. Okay. The area K of a triangle equals 1/2 the product of the two of its sides and the sine of their included angle. And so that's what I have been saying. And so that's what the theorem is. And these are the formulas you get from that theorem. Okay. So personally, I would have put this first. Confuse you with the words and then show you what it means. This is what the theorem means. This is the words that tell you what the theorem is. So we have a triangle where this is 50 degrees and one side is 5 and the other side is 3. So we're going to do 1/2 times 5 times 3 times, is it sine?
Sine.
Okay. Sine of 50. These are just remembering the formula and yes, I will provide the formulas. I have a formula chart somewhere that has all that area formulas on it.
I got 5.745 3.
Okay. And they just went to 1 decimal place. I remember you said 5.7, I didn't remember the rest. So yes. You just punch it into the calculator. With formulas, this is just plug and chug work. You plug in the numbers and you plug out the answer. So. Heron's theorem. Uh-oh. Sorry. Let's do that. All right. S, they usually call S the semi-perimeter. Semi means half. Semi-perimeter is half the perimeter. So S is half the perimeter. So you add all, and how do you find perimeter? You add the sides. You don't need any formula for perimeters of any shape. You're just adding up the length of the sides. I try and get my eighth graders not to try and look for formulas for finding the perimeter. You just add the sides up. And so it's the semi-perimeter times the semi-perimeter minus each of the sides. So let's say the triangle is 1, 2, 3. Does A, B, and C are 1, 2, and 3.
So S will be 3.
So S will be 3. And so this is 3 times 3 minus 1, which is 2, and 3 minus 2, which is 1. That's a 0. Oh, because 3, 2, 1 doesn't form a triangle, it forms a line segment. Okay, never mind. 5, 4, 7. I mean 3, 4, 5. Or some, well, let's do their example. So we have 3, 6, and 9. So the semi-perimeter is, what is that? 10? And so 10 minus 5, 10 times 10 minus 5 times 10 minus 6 times 10 minus 9 square root. Okay. So here we have 5, here we have 4, and here we have 1. So 5 times 4 is 20, 20 times 10 is 200. So that's going to be 5 square roots of I lost my count.
That's right.
20.
200.
It'll be 200.
200 is
10 square roots of 2.
Oh.
Right. 200 is 2 times 100, and the square root of 100 is 10, and 2 gets left behind. 4, 2. You always look for factors of numbers that are perfect squares when you're taking square roots. Hence, me saying knowing the first 16 perfect squares is extremely helpful. So as long as you're in a math class, knowing those first 16 perfect squares is extremely helpful. Very useful. It's not imperative, but it really helps. And then knowing the first 6 perfect cubes, 1, 8, 64, 80, no, 27, 64, no, I did something wrong. You have 1, 8, 27, 64, 125, 216. Yeah, 5 times 25 is 125. All right. Harmonic motion, damped motion, and combining waves is optional for this course. And what I do was optional. Oh, wait, I thought I deleted all these slides. Oh, I left them in there, so if y'all wanted to look at it, you could. I taught physics in Pearsall one year because they needed someone to teach physics because the person who used to teach it left the school district, and none of the remaining science teachers wanted to teach it, or at least not that year. So they asked me if I wanted to do it, and I said, sure. Like a dummy. Teaching physics that year told me I had no business teaching physics. I'm cool with the math, but the theory behind the physics, the reasons why, and I needed more time to be able to do that. And then we got into optics and wave theory. Oh man, I just got totally lost. And so, yeah, I had no business teaching physics that year. And I only had 3 students. and one of them could not, literally had no clue what to do with fractions. She's in physics and has no clue about fractions. I had a student in calculus who did the same thing. It was just, I couldn't believe it. Anyway. No, that was in Poteet. I taught in Poteet for 8 years. I loved Poteet. Okay. Polar coordinates. Polar coordinates. That means we have our graph is a concentric circles. So it looks like a bullseye. But we have radii coming out. And yes, we're going to graph things using polar coordinates. We're going to graph equations using polar coordinates. So we're going to graph functions as well. They're not functions, but yeah. Plot points, convert from polar coordinates to rectangular coordinates and back again. Transform equations between polar and rectangular forms. And okay. So this is the first section on polar coordinates. So the zero angle, yeah, is what it was in the unit circle. This is, so think of a unit circle. I always do. Just weird that way. In a rectangular coordinate system, you the point on a plane is represented by an ordered pair of numbers, x and y, where x and y equally signed distances from the point of the x-axis, y-axis respectively. In a polar coordinate system, we select a point called the pole, and then the ray with the vertex at the pole, that's our origin, is the pole. This is the polar axis. And our angle measures come off the polar axis, just like with the unit circle. A point P in the polar coordinate system is represented by an ordered pair of numbers. But now the first number is not the x coordinate, it's r. It's how far away from the pole is this point. So it's like the radius of a circle. Hence the concentric circles in the polar coordinate system. And theta is the angle coming from the polar axis. Much like in the unit circle, exactly like in the unit circle. And so we call the ordered pair the polar coordinates of the point, r theta. The first number is the radius of the circle, and r and theta is the angle from the polar axis. So to plot these points, I start by drawing this. And 2 probably should have drawn the circle first. So this point, assuming that this is exactly a circle with a radius of 2, this point falls on that circle where this is 2 units. And so the angle 4 pi over 3, isn't that down here? Isn't this 4 pi over 3? And so that point is down here, it's in the third quadrant. Two, -3, negative pi over 3. Well, it's on the same circle, but now we're going a negative pi over 3, which is this direction now, which is this angle. And there's that point. I always do it on the coordinate. I draw my x and y axes simply because that gives me the 90 degree, the 180 degree, the 270 degree, and the 0 degree, or pi over 2 pi and 3 pi over 2. Because those are good reference angles. And it's easier to see the angle that you need to draw. I don't think there's, I think this needs to be a little bit further this way, but that's my opinion. I could be wrong. 2, 0. So it's on this same circle, but the angle is 0. So that's this point right here.
So it's not polar axis?
What?
Would it be on the polar axis?
On the polar axis, which is this one. The 0 degree. So it's gonna be, yeah, right here. And then -3. How do you go -3 and 4? Well, first you find out where negative pi over 3 is. Well, negative pi over 3 is here, but I'm not going to go 3 units this way. I'm going to go 3 units this way. So it's this point over here. So I'm going in the opposite direction of the terminal side. Kind of tricky.
So the radius would say 3, but you just go the
The
opposite.
radius is still 3, but you're going the opposite. You're not going the same direction as the angle they tell you. You're going the opposite direction. So what is this angle? If I wanted to write it as a +3 and not a -3, then I need to know what this angle is. Well, add 180 to it. Add pi. So that would be the same point as 3 2/3 pi. That's the same point. Right? Okay. So 180 degrees in the opposite direction from this direction. And 1, 2, 3 units out. So this angle is going to be 2/3 pi, and going along here, that'd be a +3. That you're going in the same direction as that angle. Now I'm gonna have to erase all my beautiful work. And I didn't realize that this is all screwed up. Let me see if I can fix it a little bit. $4.98. Okay. The editors of this PowerPoint suck out loud. Okay. So we consider the point with polar coordinates 3 pi/6 in the figure. Okay. All 3 of those angles, pi/6, 13 pi/6, -11 pi/6, have the same terminal side. So these 3 points are essentially the same point. Just like I had discussed that -3, negative pi/3 is the same point as 3, 2 pi versions. But here they're dealing with 3 being the radius being positive. Okay. When we had a negative, that negative radius, the negative radius didn't mean that the number is negative, it meant the direction is opposite. Negative sign technically means the opposite. So you're going in the opposite direction. Okay. So the point. Okay. Now they're explaining the negative radius. The negative radius means you're not going in the direction of the angle, you're going in the opposite direction of that angle. So -3 7 pi over 6 is the same as this one, where these 2 angles are 180 degrees apart. They're pi apart. I subtract pi from this number, I get this number. Or if I add pi to this number, I'll get that number. All it has to do with the reference angle. I want to scream at these people who do not know how to edit their own. Well, to be honest, it may not be their fault. It may be the difference between the different. Depends upon what version of PowerPoint they use to create this. If it's the same, if it's a different version of the PowerPoint that I'm using, then we will have differences like this, where it's just the placement of the pictures. Ah, jeez. Kidding me. Okay. Let's see if I can do it this way. Yes, I can. You can't see it there. That's cool stuff. Okay. Temporary things. So plot the point with those polar coordinates and find other coordinates that have the same points, which r is positive and theta is between 2 pi and 4 pi. So you're adding 2 pi to the angle. The first one, you're going to keep 2, but you're adding 2 pi to 3 pi over to pi over 3. Because you want to go around the circle at least once. And now you want to change r to be negative. And so that means I'm going to subtract this from 180. Or pi. Yeah, these are almost always in radians or polar coordinates. And this one is very similar to this one, but we're going in the negative direction now. So you want to subtract 2 pi. No, you want to subtract pi. Or is it 2 pi? No, it's 2 pi. You want to subtract 2 pi because you want to wind up on the same angle, but going in the opposite direction. Here you want to wind up at the same angle, but you're going in the positive direction. So you're adding 2 pi to it. Here you want to go in the opposite direction. So you're going to subtract 2 pi and wind up at the same place. You can't see the grease marks my fingers are making on the board. Oh, but yeah. So 2/3, 2, comma, pi over 3 is plotted. And then you add a revolution. Let me go ahead and fix this slide. Because that's, I don't know about you, but that bugs me.
On the last slide, when it said R is less than 0, does that mean you go the opposite direction?
Yeah, okay. So this is what we're talking about. We still want to wind up here, but that means I want this angle so I can go in the opposite direction. Okay.
Yeah.
So for this angle, this would be a -2, and what is this angle now?
You would add pi to that.
Add pi. Which is what?
2 pi over 3.
Add pi to pi over 3. So that would be adding 3 pi over 3. So that gives us 4 pi over 3. Because now, instead of going 2 units this way, you're going to go in the opposite direction. Negative signs when you're talking length only talk about direction. Doesn't make the number negative. It tells you you're going in the opposite direction than the angle is telling you. It's like in football, when you lose 5 yards, you didn't go into a negative zone, you went 5 yards in this direction rather than that direction. Football is the easiest way for me to explain negative numbers. I've never been big into football, but it's very helpful in explaining certain concepts. Oh, I was gonna fix some things. The rest of it's okay. All right. So that would be 7 pi over 3. So that's going around once and then winding back at the same angle. And this one. Yeah, and I already did that one. So we're gonna go this way. To wind up there. So where positive 2 would take us down here, this is B2, 4 pi over 3, but we want to go in the opposite direction. So when we go through the pole. Their picture is much prettier than mine. Oh, And then. Jeez. To get a negative angle, we subtract 2 pi, and subtracting 2 pi is going in this direction. And you wind up at the same place. And that's gonna be 2, what was it? Pi over 3 minus 2 pi. So 2 pi minus, so 6 pi minus, so that's a negative 5 pi. A negative 5 pi over 3. It's in my hand. And so, yeah. So it's that. Still wind up at the same terminal side, the same terminal angle, but you're just going in the opposite direction. In one case, you passed it by and then came back to it. They weren't sure where they're going, so they drove by it by accident and had to come back to it. Converse pair, conversion from polar coordinates to rectangular coordinates is a simple formula. Remember that x is the cosine of theta. With the unit circle, the radius is 1. Boom. Same thing with the y. The y is the sine of theta with a radius 1. So if I wanted to convert, what was that original point? To, is it pi over 3? Pi over 3. So that x is going to equal 2 times the cosine of pi over 3, and the y is going to equal 2 times the sine of pi over 3. Well, the cosine of pi over 3 is 1/2, so this is 2 times 1/2 or 1, and y times 2 times the sine of pi over 3. Well, the pi over sine of pi over 3 is the square root of 3 over 2. So that's just the square root of 3. So this point in polar coordinate, in rectangular coordinates, is 1 square root of 3. And that's how that works. In one class, I don't think, it may not have been this class, I mentioned this back early on when we were talking about x being the cosine of theta and y being the sine of theta on the unit circle. I think this formula would make some things much easier to deal with. But anyway, our sine theta, our cosine. So one way of listing the ordered pairs is R cosine theta, R sine theta. That's listing this point in polar coordinates. I just apply the formula directly and write it that way. Now find the rectangular coordinates of the point with the following polar coordinates. So we just plug it into the formulas. 2 times the cosine of pi over 4 and 2 times the sine of pi over 4. The sine and cosine of pi over 4 is the same number, so the x and y values are going to have the same. And they're both going to be the square root of 2. Square root of 2, square root of 2 is the rectangular coordinates here. Right, so this lies in quadrant 1, so the x and y are positive. So that's something you take into consideration. What coordinate, what quadrant do you wind up in, and that tells you whether the x or y is negative or positive. Okay. Oh, that one is way off. What are you doing to me now? The rest it's okay. And so we do the x is the radius times the cosine of pi over 4. 2 times the cosine of pi over 4, which is the square root of 2. And the y is going to be the same number. Because the line that contains the angle pi over 4 is y equals x, where x and y have the same value. And so that's the point. Square root of 2, square root of 2, which is quadrant 1. Now they're just being bastards. I look at this visually, because that's how I operate. Negative pi over 6 brings us over here. And this would be 2. So we want to go in the opposite direction. And it's this point over here. Right? Because this is positive 2. This is 2 negative pi over 6, but we want the opposite direction, so this is negative 2 pi over 6, negative pi over 6. So we're going to wind up in the second quadrant where the x value is negative and the y value is positive. Let's see how they deal with this, because I would deal with it in one way and they deal with it in a different way. So they're going to do the direct conversion. Okay, it lies in the second quadrant. This is what I saw. And so putting those numbers in there appropriately, cosine of a negative angle is the cosine of a positive angle, and the cosine of this is square root of 3/2. So this will be a negative 2 times, or a negative square root of 3 is what x is. And then the y value is going to be positive, because where we're winding up, because the sine of a negative angle is the negative sine of the positive angle. The sine of pi/6 is 1/2, and so the negative of that is a negative 1/2, and negative 1/2 times 1/2, negative 1/2 times 2 is a positive 1. So the y value is 1. So that point is negative, and that winds up here, right? Negative x and positive y. Someone needs to mute themselves.
It's already been a minute.
Okay. So. Yeah, that's one way. Okay, so we'll deal with this next time. Coordinates. Oh, the rectangular coordinates is 2, 0. Or 0, 2. That's interesting. Okay. Unless you have questions for me, you are free to go. We'll go ahead and start on this slide next time.
Yes, sir. Hello.
Yes.
Okay, I'm sorry. I had a question. I remember last time someone asked you if we had any chances to retake the test, but my computer went off before you answered the question, so I was gonna ask you this time.
Okay, have you taken the test?
I took the test.
Okay, I do not do retakes.
Oh, okay.
Okay, so,
All right.
and one reason why is because you have a chance of the final replacing your lowest grade.
Oh, okay, makes sense.
So if you make a good grade on the final, or a better grade on the final than you made on this last test, it can replace it.
Oh,
If-
okay.
If this is the lowest exam grade you got.
All right. All right, well, thank you.
All right,
Bye-bye.
bye-bye.
I just had
You want to see yours?
yeah, if possible. I just had a question on the grading. Because when I took it, it said out of 140 possible points. But was the grade you gave me, but it said a 94, was that 94 out of 140, or was that like 94 out of 100?
What I posted in the grades
Yeah,
is on a 100-point scale.
okay, good. I was worried for a second, I was like, because that's between like.
No,
an
no,
A,
no, 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 no,
B,
no,
and
no.
a C and
What
F, so I was like,
yeah, the raw score
is that?
is the raw score is what I put on the exam itself. And then I convert that to a 100-point scale.
Okay. I was confused, I got worried, so I wasn't sure.
Because I do more than just what that score is. Because I did a curve on that test, on both tests. It was a 0.75 times your grade plus 25. And so if you made less than 100, well, actually less than a 98, it changed your grade.
Okay.
A 99 stayed a 99, a 98 in most cases stays a 98, but all the other grades go up.
You said the final would replace the lowest grade,
The lowest grade, yeah.
so would the final go, if it's lower than all the other tests, would it still affect the grade?
If the well, because the final is still part of your grade. Because how I calculate the grade, you have the first 3 exams. And this is. Is this, I can't remember what it is. I think it's either, sir, I gotta look at my grading scheme, because I changed it since I used to do this. And your final grade is 30%. And so that will give you your grade for the class. But what I do is, I will replace one of these, the lowest one, with your final, if it's higher than that grade. So if you made like a 60 on this test and you made an 80 on the final, then that 60 becomes an 80. Okay. Now, I had one person who they had like a 98 and a 95 and a 96, and their final was a 92. Not that it would affect their final grade anyway, because it's just A, B, C, D, or F, so. So an A is an A is an A. Does your school for calculating your grade point average use the number grade?
Oh, no. Well, you can, if I get higher than 98 in the course, that could help my rank at the high school.
Okay.
But if I don't, then it just,
Yeah, it's just A, B, C, yeah. So it's 4, 4, 3, 2, 1. And A is worth 4 points. B is worth 3 points. So 4 times, this is a 4-hour course, so 4 times 4, so you get 16 points for this course. I had no idea how they calculated high schools. I had none whatsoever.
no, I just think they get the letter grade and that's what they. put
I was in the top 25% of my class of 524 students. So I wasn't anywhere near the, yeah, I was a B student in high school.
I'm trying to get top.
Yeah, I hear you. So, yeah. I think coordinates, the polar coordinates is easy.
It's just.
Once, yeah, it's knowing that formula. X is R theta. I mean, R cosine theta and Y is R sine theta. The first number is how far out you go on this angle.
So if you don't do the homework, would it negatively impact your grade besides like practice wise?
Is it a 10% homework?
No.
No, it's just a test.
If you make under an 80, 15% of your homework average is added to your test score. Up to an 80.
Because I have a little bit over half of the assignments done, but they've taken me like 6 hours to do one assignment or something.
You're at a level where you do the homework so you understand what's going on. Because you're at a level where you don't need to worry about that 15 points.
So the homework is not required. It helps us.
Technically, it is not required. It is required in that that's where you learn the material.
A lot of that I've seen before, so like, I didn't necessarily need to do like 60 questions on it, but like, a lot of the, like, the first chapter, the first exam, I'd seen like 99% of those concepts.
It's because I would do the homework and then I would get stuck on like 3 problems and those 3 problems I would be stuck on all week and I would be repeating it until I got it right. And it
Well,
would
that's
take
when
over
you
time.
send me an email. You say, hit ask the instructor.
I asked you once and you said we're not on that yet, and I was like, never mind, I'm not asking again.
Oh, don't do that. Don't do that. Don't ever let me say something like that stop you from asking me questions?
You said, no, we're not on that concept yet, but then. I don't- okay. I
But
figured it
when,
out.
but when we get there, yeah. I'll answer that question, but right now, right then, I was more focused on other things.
It's because in the Zoom meeting, when I was in the Zoom meeting, I have a Chromebook. I can't see your screen at all. At all.
Oh.
And the high schools provide the Chromebook. So your
So-
screen looks blurry and whatever you write on the board, I can't see.
Yeah.
Yeah.
I did have a little bit of an issue with that. I had to listen to what you were saying and write.
And
what
write
you-
it down,
what
yeah.
you- I had to say what you, I had to write what you were saying. Because the screen gets kind of blurry.
And then if you made a mistake, I would be lost. That was the end of it. Because if you made a mistake, you erased it somewhere on the screen, but I don't know where it was at.
I usually zoom. But yeah, it's kind of, it's hard to follow even on my monitor.
Oh, I can't zoom in the Chromebook. I can't zoom in and Zoom, which is ironic.
That's pure shit. Okay, well, let me close it. Let me close the flash now.